Okay, so hello everyone again. This is lecture 5 part 3 of wave optics. Today we will be going in the further discussions of interference of light waves and Thomas-Young's experiment. I am Samir Lavankar. Let's begin. Okay, so course outline for you, we started with the introduction concept, that is the why is wave optics necessary, how it is different from the Descartes wave theory. In the Huygens principle, I explained to you what is wavefront principle, and if we need to find out the value of wavefront at some time t is equal to t, given that we know the wavefront at some time t is equal to 0, it can be calculated directly. The third was the explanation application part of Huygens principle only, in which we find it out in the third part, and we tried to prove the refraction and the reflection loss of plane waves only. In the fourth point, I explained to you what is coherent and incoherent addition of waves. In this I explained to you what should be the intensity for coherent. So, for coherent it is 4 I naught or 2 I naught, and for incoherent it is always 0. In the last point, so now in the fifth point which we are discussing right now, first of all we try to explain why there was a need for a single source to occur. So, if there is a single source to occur, then that means the phases are locked. If the phases are not locked, then we cannot calculate, because we need the phases to be locked only. So, finally in the last explanation we were discussing about Thomas-Young's experiment, in which we calculated the value of that x at which we can calculate maximum fringe maximum intensity or minimum intensity. So, for maximum intensity it was n lambda capital D by small d, and for minimum intensity it was n plus 1 by 2 lambda capital D by small t. Finally, the last lecture was concluded with the fringe width concept, which is equal to lambda capital D by small d always. So, just going to that revision only for fringe width, and then we will move on to the further discussions. So, this is the for constructive interference, the value of x should be n lambda capital D by small d, and for the dark fringe it is n plus 1 by 2 lambda capital D by small d. Finally, the fringe width concept was being explained, which is nothing but the distance between the two consecutive bright and dark fringes. On mathematical calculation, we find it out that its answer is equal to lambda capital D by small d. Okay. So, now let us move on to the further discussions for this Thomas-Young's experiment and interference of light. So, this diagram is actually known to you, just I will explain to you again. So, what is happening here is, so there was a single source of light on this part here, then there was a pinhole. So, this was a cardboard C1, this was a cardboard C2, and this was the screen. So, this screen is denoted by capital G dash. O is the center point which is passing through this source S or this pinhole S, and then now, and this is for cardboard 2. So, these are the these are again pinholes. The distance between these pinholes are denoted by small d. The distance from these sources or this pinhole, that is S1 and S2, to this screen is denoted by capital D given here, and then any point, any arbitrary point for which we need to find it out if it is having a dark fringe or it is having a bright fringe is denoted by small x. So, this is the complete explanation of the figure drawn here. Let us move on to the discussion now. Okay. So, obviously the central point O will be bright because S1O is equal to S2O, and it will correspond to small n is equal to 0. So, in the last lecture also I tried to explain you using this diagram here, that at x equal to 0 it is quite visible that you will get a bright fringe. A bright fringe is nothing but a white fringe. So, obviously the center point O will be bright because S1O is equal to S2O. So, how it will be equal? Quite evident, you can see from this also. So, as the even if we take the congruency of this triangle, let me try to make it using different colors. So, first of all, so this is S1O for you and this is S2O for you. So, quite evident that S1O will be nothing but again d by 2, this will be also d by 2. This distance, let me denote this as, let us say, some m value. So, this MO is common value and this is 90 degree. So, from SAS congruency property, that this triangle S1MO and S2MO are congruent, and because it is congruent, that means S1O is equal to S2O. So, obviously the central point O will be bright, and because S1O is equal to S2, and it will correspond to n is equal to 0. So, because n is equal to 0, that means that S2P minus S1P is equal to 0, and because it is 0 we know that x is equal to nothing but n lambda capital D by small d, because n is 0, x is 0. So, both things mathematically and even by visual inspection it is quite evident that at x equal to 0 it will be a bright fringe. Now, if we consider the line perpendicular to the plane of the paper and passing through O, that is along the y axis. So, now just let me rub it here and I will try to explain what is being explained in the next point here. So, let us say this is cardboard C1, this is cardboard C2. So, now what is try to explain is, if we consider the line perpendicular to the plane of the paper and passing through O, that is along the y axis, then all points on this line will be equidistant from S1 and S2, and we will have a bright central fringe which is a straight line as shown in the last figure. So, what does it try to explain is, I will try to explain this concept using some last figure. Okay. So, as this is the point O being talked about here, let us say I try to make a triangle also for more clarity. So, this is the triangle S1O and this is the triangle S2O. So, now what happens here is quite evident, as I explained to you in the last concept also, that S1O and S2O were equal. So, if it is equal, even if, so now please look out to this point here. So, if this point is equal, even if we try to change this point perpendicular to the plane of paper. So, let us say this is the perpendicular plane of the paper and this is that point O we are talking about. Let us say this is the source S1, this is the source S2. How will I explain? Let us say explain that this is the source S1, this is the source S2. Now, this is the point O which is in center of this S1 and S2 sources. Now, if I try to change this portion either towards left or either towards right, please make sure it is perpendicular to the plane of the paper. Perpendicular to the plane of paper as in its movement is always sway movement only. So, what happens is, let me make a different diagram for now. So, if I try to find it out, if the distance of S1 to that point, let us say this point is some P dash. So, this point for P dash, if it is same only. So, these are two triangles being formed. Maybe from this view you cannot explain, I cannot explain you that these two triangles are congruent, but for if the mathematical calculations are done, then also these both triangles are congruent, and because these triangles are congruent, that means S1O is equal to S2O, and because S1O is equal to S2O, that means it is corresponding to n is equal to 0, and if it is corresponding to n is equal to 0, that means it is also having a bright fringe. Therefore, at any point, not only depicting the center point, at any point which is perpendicular to the plane of paper, always there will be a white fringe. So, just iterating it again. So, if we consider the line perpendicular to the plane of paper and passing through O, that is along the y axis, then all points on this line will be equidistant from S1 and S2, quite evident, and we will have a bright central fringe which is a straight line as shown in the last figure. So, this is the bright central fringe being talked about here. Okay. So, now in order to determine the shape of the interference pattern on the screen, we note that a particular fringe would correspond to the locus of points with a constant value of S2P and S1P. So, what does this line try to explain to you is, any fringe whenever it is formed will its shape either can be a curved shape, it can be a straight shape. It depends on the locus of S2P minus S1P. So, at any point, let us say I from the last concept I explained to you that S2P minus S1P can be either equal to n lambda and S2P minus S1P for coherent addition, and for incoherent addition it is n plus 1 by 2 lambda. So, at any point where it is, let us say I explained for n is equal to 1. So, for n is equal to 1 it will be lambda, for n is equal to 1 it will be lambda by 2. So, for the locus of points at which the distance S2P minus S1P, that is the difference between the two sources, is always a multiple of lambda, or it is always lambda, or it is always lambda by 2, then that only this will be 3 lambda by 2 if n is 1. Then only those points will have a same fringe. Why it will have a same fringe? Because the phases are locked. If the phases are locked, that means the intensity coming from the exact same independent source will be always same. So in order to determine the shape of the interference pattern on the screen, we know that a particular fringe would correspond to the locus of points, with the constant value of S2P minus S1P. That means at any point at which, so we can take any random point. Let's say I take this point as random. So whenever we try to calculate here, the random point which we get are always a straight line only. Hence we find out a fringe in a straight line. So whenever you try to find it out, let's say I took the distance, let's say I took this point as P first, then I took this point as P, then I took this point as P, similarly I took this point as P. So whenever I try to find it out, the distance S2P minus S1P, it was always coming equal to 0. Similarly, let's say I try to find it out for this fringe here. Let's say I took this locus, or I took this point and I tried to find out the value of P. When I tried to find out the value of P, it was always coming equal to 2 lambda. Why it is 2 lambda? Because it is 0 for this, then it is 1 for this, and this lambda, and this is 2 for this. Hence it is equal to 2 lambda. So this thing is also explained to you. Now whenever this constant is an integral multiple of lambda, the fringe will be bright. Quite evident, I explained to you also. So this, please remember these concepts. And whenever it is an odd integral multiple of lambda, it will be dark. So this is already explained to you. Now the locus of the point P lying in the xy plane such that S2P minus S1P is equal to delta lambda is a constant, is a hyperbola. So what does it try to explain to you here is, why is there a, I explained why are there curves like this. So why it is curved like this? Because whenever we need to find it out for any multiple which is not n lambda, which is not a multiple of lambda, or it is n plus 1 by 2 lambda, then always S2P minus S1P is equal to lambda, and this is an equation of hyperbola. Thus the fringe pattern will strictly be a hyperbola. However, if the distance capital D is very large compared to the fringe width, the fringes will be very nearly straight lines as shown in the last figure. So now I explained to you why. So what is happening here is, these two diagrams are same only, but see, as you can clearly see here, that small d here was 0.005 meters and small d here was 0.025 meters. So because there was a change in the small d value, on the simple explanation, first of all, the assumption being put was that these both values should be less than capital D. So if it is very less than capital D, then these hyperbolas take form as very nearly straight line, because the focus or the radii goes into infinite values. If it goes into infinite values, then the lines, these hyperbola lines, comes as single lines, or not single lines, straight line. But if it is not a very small value, then these are shown as hyperbola. So just to explain to you, just to remember, always interference fringes are always hyperbola only. But because if we take an assumption, or if we take a case out of this in which we find it out that small x and small d are very less than capital D, then at that point this value, these fringes will be straight lines. This is the final conclusion of this concept here, that the fringe pattern will strictly be a hyperbola. However, if the distance capital D is very large compared to the fringe width, so what is fringe width here? Fringe is nothing but small b. So in this case, this fringe width was very large, which is 5 mm, and in this case it was small, which is 1 mm. So the fringes will be very nearly straight lines as shown in the last figure. So this is also explained to you. So this was the final conclusion of this slide. Moving on to the next slide now. So in the double slit experiment, so why it is called as double slit experiment? Because two slits are being used here. So in the double slit experiment shown in the figure, we have taken the source hole S. So this is the source hole S. What does this source hole means? That only a single source of light is coming from this portion here. On the perpendicular bisector of the two slits, which is shown as the line SO. So this is the line SO being talked about here. This is the line SO. So in the double slit experiment shown in the figure, we have taken the source hole S on the perpendicular bisector of the two slits, which is shown as the line SO. If the source S is slightly away from the perpendicular bisector, consider that the source is moved to a new point S dash, and suppose that Q is the midpoint of S1 and S2. So what does it try to explain us? Let us explain, let us take for a case that this source S is moved apart. So if this was the source S, if this was a pinhole S, let me now explain, and these were the two slits S1 and S2, and this S1 is now at this point, it is slightly deflected from this point, and let us say that new point is S dash, and suppose that Q is the midpoint of S1 and S2. So now if Q is the midpoint of S1 and S2, if the angle S dash QS is phi, then the central bright fringe occurs at angle minus phi from the other side. So if I try to explain, if is there no diagram is given, so I will try to explain you from here only. So let us suppose that this was S here, and now let us say this is the S dash here. So what does it try to say is, because a central bright fringe only and only occurs when the distance S1O and S2O was same. So on calculation it was found that this distance is same only and only when it is deflected somewhat above. So this is that point. So because this distance, let us say this distance is this angle, which angle is being talked about? S dash Q dash, na? So S dash S Q. What is the point Q? Q is this point. So if this angle is given to you as phi, so because there was a change in the downward direction for this, it is saying that direction shown here, so here that will be phi in the above direction. So this is only the explanation being explained here, quite evident also. So I will try to explain you from this diagram also here. Let us say this is S, let us say this is S dash. So if it is moving downwards, it is moving downwards, quite evident at the complete screen, will be showing the interfringes in upward direction. So if there is a difference, or if there is a change in the downward portion here, then for this portion the angle will be formed in the above direction. So because the rotation is in clockwise in this direction and anti-clockwise for the screen part, hence it is shown denoted by minus phi here. So just explaining the line again. So if the source S is slightly away from the perpendicular bisector, consider that the source is moved to a new point S dash, and suppose that Q is the midpoint of S1 and S2. If the angle S dash Q dash is phi, if the angle S dash Q dash is phi, so let me explain this as phi, then the central bright fringe occurs at angle minus phi on the other side. It is occurring at the minus phi on the other side as in either above or either below. Thus if source S is on the perpendicular bisector, and the central fringe occurs at O, also on the perpendicular bisector. Quite evident that it is a simple explanation. So if S is here, then the perpendicular bisector is here, because the angle phi is 0, that means the angle is also formed at angle phi is equal to 0. So this is the only explanation from this point. And finally, if S is shifted by an angle phi to point S dash, then the central fringe appears at a point O dash at an angle minus phi, which means, now please look over this line very carefully, which means that it is shifted by the same angle on the other side of the bisector. So what does it explain by other side of the bisector? If I explain you, so this is one side, let us say denoted by 1, and this is S2. So if this is S dash, this is that point Q we are being talked about, and this is that angle phi, then if the fringes are being formed on the above side, so if the angle is being formed in this side, then the fringes are being formed on the other side. So this is the only explanation being talked about in the last concluding point here. If S is shifted by an angle phi to the point S dash, then the central fringe appears at a point O dash at an angle minus phi, which means that it is shifted with the same angle on the other side of the bisector. It is shifted on the other side of the bisector. This also means that the source S dash, the midpoint Q, and the point O dash of the central fringe are in a straight line. So what is the straight line being talked about here is, so this is that point O dash, this is that point G being talked about, and this is the point S dash. So this is saying that this is also mean that source S dash, the midpoint Q, and the point O dash of the central fringe are in a straight line. So this was the final conclusion of this experiment today. In this complete lecture of lecture 5, I explained to you what is interference of light, what is Thomas-Young experiment, and further discussions were being done on where to find out the bright fringes, where to find out the dark fringes, and finally a simple experiment was being done if we change the distance or we deflect the source point S to some point S dash. So then also the fringes are being found, but they are slightly deflected from its original position. So let me conclude it here only. So the course progress for you, we have completed with the first introduction part about wave optics, then Huygens principle of wavefront is also being done. Then third is the explanation of proof of refraction and the reflection laws of light using plane waves concept. Finally was coherent and incoherent addition of waves, and today we are done with interference of light waves and Thomas-Young experiment. A little bit more discussion is also required for interference of light waves, which will be done in the subsequent slides. And finally, after the fifth point is done, we will go to two different applications of wave optics, that is diffraction and polarization, and that will be the end of wave optics. So for now, thank you.